Good morning everyone. In our last video, we have seen a rate of change of velocity. Some basic concepts according to which is we call a acceleration. Right? What is acceleration? The acceleration is rate of change of velocity. Means the change in velocity per unit time, which is known as acceleration. And according to it, we have our equation a is equal to v minus u by v, in which the a is acceleration, v is the final velocity, u is initial velocity, and the t is time. So according to it, we can say that the acceleration is equal to final velocity minus initial velocity divided by taken time. Today we are going to see some of the examples related to the acceleration. Page number 103. Example 8.4. Rahul starts pedaling from the stationary position of its bicycle. It attains a 6 meter per second velocity in a 30 seconds. After that, it applies a brake, due to which the velocity decreases to the 4 meter per second in 5 seconds. Calculate acceleration in both the cases. So there is a two cases. The first case is there, Rahul starts pedaling, right? He starts pedaling. It is the case number 1. And the second case is there when he applies a brake. So here, but 2 times acceleration is changed. The 2 times velocity is changed. When he starts pedaling, during that time, his velocity is increases, and when he applies a brake, the velocity decreases. Right? So there is a 2 cases. Example 8.4. So case number 1. In first case, what he is doing in this case? He just starts pedaling. Means before pedaling, the bicycle is in a stationary position, right? So according to it, you can say that the initial velocity of bicycle is 0 meter per second, because when he starts pedaling, he attains some speed or a velocity. Without it, the bicycle is a stationary, right? So before a event, right, at here, the first event is pedaling a bicycle, the first thing. Right? So, before it, the cycle is stationary, so the initial is 0 meter per second. Right? After that, it attains a 6 meter per second. That bicycle attains a 6 meter per second velocity, which is the final velocity, which is 6 meter per second. And the time taken for it is 30 seconds. So in first case, you have to find out the acceleration. A is equal to v minus u divided by t, where the v is 6, u is 0, and the t is 30. So 6 by 30. T 2s are 6, 10 is 30. So 2 by 10 is equal to 0.2 meter per second square. So A is equal to 0.2 meter per second square. Now, case number 2. What happens in the second case? He applies a brake, and just because of that, its velocity decreases by a 4 meter per second in time 5 seconds. So during that time, before brakes, the velocity is the initial, which is 6 meter per second. When he starts pedaling, then you can say that before pedaling, the velocity is 0. After pedaling, the velocity is 6. But when he applies brake, before brakes, velocity is 6. And after brake, the velocity is 4 meter per second. The time is 5 seconds. Now you can easily find out acceleration v minus u divided by t, where the v is 6 and the t is 5. So it's a minus 2 upon 5. So the acceleration is equal to minus 0.4 meter per second square. Minus just shows that the acceleration is in the opposite direction of motion, right? As the acceleration is positive, you can say that that object is moving in the direction of motion. If the acceleration is positive, so it is in direction of motion. Here the acceleration is negative. It is opposite to motion. Because we applying a brakes, the force is in the opposite direction of motion, so you can say that the acceleration is also in the opposite direction of motion. Or you can say that due to this value, a negative value shows that the initial velocity is higher than the final, right? If it is negative, then the u is higher than v, and if it is positive, then the u is less than v. So here it is your example number 8.4, right? Just watch it for 2 to 3 seconds. Okay. Now, another examples. Okay. On that page, there is some question is given to you at the last, right? First question, you have to just write down the definition of uniform acceleration motion and the non-uniform acceleration motion. But the second question is the sum related to the acceleration, right? A velocity of a one bus is decreases from the 8 km per hour to the 60 km per hour in 5 seconds. What is the acceleration of that bus? A velocity of bus is decreases from 80 km per hour to the 60 km per hour in 5 seconds. What is the acceleration? Question number 2. Okay. In this example, you can easily find out which one is u and which one is v. The initial one is 80 km per hour. After it decreases and becomes a 60 km per hour. So first of all, u is 80 km per hour. As you know that we have to convert it into meter per second in SI unit. So according to it, 80 into 1000 divided by 3600. So it's 0, 0 cancel out. 4 2s are 8 and 9 4s are 36. So it's a 200 by 9 meter per second. Now V is 60 kilometer per hour. So 60 into 1000 divided by 3600. 36. So 100 by 6 meter per second. And the time is 5 seconds. You have to find out the acceleration. So A is equal to V minus u divided by T. The V is 100 by 6 minus 200 by 9 divided by 5. If you want to divide both of them, then you have to take the LCM. What is the LCM of 6 and 9? 2 3s are 6, 3 3s are 9. So 3. So it's a 3 into 3 into 18. So 300 minus 400 divided by 18. So the A is equal to minus 100 divided by 18 into 5. Right? Exactly. That one is as a denominator. 18 is also denominator. Right? It is not the denominator of denominator. 5 is not the denominator of denominator. Both are the denominator of 300 minus 400. So you have to take it as a multiplication. Understand? Like meter per second is the unit of V minus U. Divide by second, like that. The second is not the denominator of second. Second, this second is the denominator of whole this one. So you can write like that, meter by second into second. The same thing as is at here. 5 is the denominator of whole thing, right? So both are also the denominator of this one. Okay, so whenever you want to do this type of sums, you have to take the multiplication of this one, 18 into 5. Understand? So at here, A is equal to minus 100. So at here, 0, 0 cancel. So A is equal to minus 1, so you can say minus 1.11 meter per second square. And here you can also see that the velocity decreases just because of that acceleration is negative. And you can say that person should be apply a brakes. So the acceleration is in the opposite direction of motion. Acceleration is in opposite direction of motion. Just see it. Now, next one. The third question. One train starts its journey from one railway station and with the constant acceleration motion it attains a 40 km per hour in 10 minutes. What is the acceleration? A train starts its journey from one railway station and it just moves with the constant acceleration and attains a 40 km per hour in 10 minutes. You have to find out the acceleration. So question number 3. First of all, train starts its journey from railway station. So during that time, its initial velocity is in meter per second. From railway station, it starts its journey, right? Then it attains a 40 kilometer per hour speed. So it's a V which is 40 kilometer per hour. We can convert it into meter per second. So it's 100 by 9 meter per second. What is the time duration? The time duration is 10 minutes, which you have to also convert it into second. So it's a 10 into 60. So it's a 600 seconds. Now you have to find out the acceleration. A is equal to V minus U divided by the V is 100 by 9 minus U divided by 600. So it's 100 by 9 into 600. 1 by 50 meter per second square. So the A is equal to 1 upon 54 meter per second square. Here is the acceleration of that train. Right? It's the acceleration by which it just moving and attains a 40 kilometer per hour in 10 minutes. Okay, now on that page there is one activity is given to you in which you have to just give some of the examples related to it. So first of all, when the acceleration is in the direction of motion, so whenever the acceleration is positive, or you can say that when the velocity of object increases, then you can say that that acceleration is in the direction of motion. Whenever you are riding a bike and you are just giving an acceleration, during that time the acceleration is produced, during that time the velocity is increased. The velocity of that object is increases. During that time you can say that the acceleration of that object is in the direction of motion. Right? So there should so you have to give some of the examples related to it. Okay? Now the second one. Acceleration is in the opposite direction of motion. Whenever the velocity decreases, you have to say that during that time the acceleration is in the opposite direction of motion. So whenever we are applying a brake, during the time the velocity decreases and the acceleration is in opposite direction to the motion. Now, whenever the acceleration is constant, acceleration constant means uniform acceleration motion, in which the value of acceleration is same. Or you can say that the change in velocity is same in same interval of time. Whenever you drop some of the object from some height without using a force, free falling, just you have to release them. During that time, the velocity is increases by 9.8 meter per second in each second, right? In each second, the velocity increases by 9.8 meter per second. So you can say that the acceleration is 9.8 meter per second square at each and every second. During that time, you can say that it's the acceleration of that object is uniform. Whenever you just throw it in an upward direction, right, which is exactly perpendicular to the surface of Earth, during that time also the velocity is decreases by the same rate. Same rate, it just decreases at a 9.8 meter per second in each second. So you can say that during that time also the acceleration is same, because if the velocity is same, it's known as acceleration. It doesn't mean that the velocity increases means acceleration. If the velocity increases or decreases, both known as acceleration. You have to just take a change of velocity, right? So whenever it is increases by the same rate, during that time also it is uniform motion, and when the velocity decreases by the same rate, during that time also the acceleration is uniform, right? Now the acceleration is non-uniform. You can see it everywhere. Whenever you're riding a bike, if due to the traffic, you have to just decreases your velocity according to the traffic. Not only that, whenever you move on a clear road, there is no traffic, then you are just increases your speed, but the rate of that increase of speed is not the same. Sometimes you are just riding at a more faster, but sometimes it is just less as compared to the other one, right? So you can say that acceleration is not uniform. Sometimes it is decreases, sometimes it is increases. Not only that, the rate of the change is also not same. So we can say that here it is the acceleration, non-uniform acceleration. So there is some acceleration in the direction of motion, or acceleration in the opposite direction of the motion. Sometimes you can say that it is uniform or non-uniform. You have to just write some of the examples related to it. Okay, according to the activity 8.8. Okay, now another topics will be seen in a next lecture.